Welcome to the Grid Mod Pod, brought to you by AEIC. In this podcast, you'll hear from the utility industry's top operations leaders on how their companies are working to modernize and improve our ever-evolving power grid. Thanks for joining us.
Welcome back, listeners of the Grid Mod Pod. I'm here today with an exciting guest that kind of has a very broad perspective of many items, things in regards to grid modernization, really around operations, the markets, and really the strategy behind where we are, where we're going. So I look forward to this conversation. So we have Brita. So Brita, thanks for jumping on today and sharing your knowledge and your journey in the space that we're in. So for our listeners, take the opportunity to introduce yourself and kind of the company that you're within, and then kind of we'll jump into the discussion for today.
Thank you, Elizabeth, for having me on. So just a little bit about my background. So I've worked in the energy industry for over 25 years. Maybe go back a little bit in history, where I grew up in Norway, which is an energy-rich country. And I first came to the U.S. to go to school, to go to college. I went to college in Florida, and I went to graduate school for business at Columbia University in New York City. So my first job out of college actually went back to Norway, and I worked for Equinor. At the time, it was called Statoil. It's a Norwegian large major oil company. And I worked there in several different roles. And then I worked for ExxonMobil, actually worked both for Statoil in Norway and in the US, and then moved on to work for ExxonMobil in the downstream business. So I spent about 10 years in the oil industry. And then I moved on to the power industry about 19 years ago when I joined Duke Energy. And there I had various positions. I worked in M&A for a while, mergers and acquisitions. And that's where I really got my first taste of renewable energy. I led their acquisition of their first major renewable portfolio, which was onshore wind assets. And then I led the risk management for the US and then also the international business, which was 7 countries in Latin America. So of different power companies and 7 different countries in Latin America. And then I worked on the company's capital plan, optimization of the plan, which was over $50 billion at the time. I'm sure it's bigger now, but at the time, transmission and distribution was a big portion of that. So just prior to joining Heimdall Power, who I am working with today, I worked at a floating offshore wind technology company. I was leading the company in their efforts to get their first offshore deployment of a small test turbine off the coast of Massachusetts. And then I learned about Heimdall in 2023, and I was really impressed with the company's technology and also the people, and also the culture of the company. So I was compelled to join them. It is really just a perfect opportunity to bring together all my energy industry experience into the work that I'm doing today with Heimdall Power.
So this is lovely. One thing about the grid mod, the big kind of the objective and really the goals of the podcast is to bring in the multiple perspectives and leaders across the industry. So what I heard was more or less you've been at the forefront of over 2 decades globally, touching and having an impact on the oil, gas, renewables, and kind of the electric utility space. So I love it. It's really exciting. And then in regards to where you are now, the technology that you're leading is really all about optimizing the power grids. So yeah, what I would love to hear a little bit more about, Heimdall Power and where you are and what that technology is. And then we'll jump into really one of our favorite topics, I will say, on the Grid Mod Pod is, I started this journey of this podcast talking about the complexities and the transformational change happening in the distribution grid. But very quickly, we realize, this is all about 4 parts: generation, transmission, distribution, and the edge, aka customer. All 4 components are required and necessary for this transformational change that we all have yet to realize. And so our transmission grid is getting a whole lot of attention. So I think, we'll spend most of our conversation there, but I'd love to hear, the technologies that you guys are embracing and kind of making, your strides to bring the industry to be aware of what you're up to and what they can do to benefit.
Yeah, so Heimdall Power. It's a Norwegian-born company in 2016, and it really helps utilities to optimize their power grids through real-time monitoring of their power lines. So that's with predictive maintenance and data-driven operations. And there are more than 50 employees working out of the office in Oslo, Norway. And then we have our North American headquarters in Charlotte, North Carolina. We also have employees in Houston and in California. So we have an industry-leading technology that really has proven to increase transmission capacity and also reliability, safety, and efficiency really of the grid. So we do that through the DLR, so dynamic line rating, and that is just a quick background of what that is.
Or kind of for our listeners that maybe haven't, in the world of GETS, grid enhancing technologies, there's a cornerstone of technologies that is being utilized and becoming available, and utilities are slowly implementing dynamic line rating. So, for our listeners, kind of what is it fundamentally? Break it down, and then we'll kind of talk more.
Okay, so what is dynamic line rating? So the tagline of Heimdall Power is the power of knowing, and that is really exactly what dynamic line rating provides. It provides the power of knowing real-time data on the condition of the power lines, of the grid. So that gives line current, the voltage, the inclination, the temperature and movement of the line, right? So to mention a few things. But the temperature of the line is really the limiting factor, because if you get the warmer, the more heat on the line, the more it can sag, that the line will sag. And it's that clearance of the ground, make sure that you have a safe clearance to the ground, to any kind of infrastructure or even vegetation, right? That is the safety. So that's kind of dynamic line rating in a nutshell. But if you think about, you have the Garmin watch, right? That will give you your heart rate, your sleep score, and also your HRV. The sensors that we deploy for dynamic line rating does the same thing for the power grid. We'll give all sorts of conditions on, information about the conditions real time to the utilities, so they know how much more capacity they have left on the line, or if they don't have any more capacity on the line. Maybe more importantly,
I can't help myself, because dynamic line rating is kind of a sweet spot for myself. When I was leading the transmission planning organization at the utility I worked at, it became, this was before the data center charge of we need to triple, maybe times 10, the capacity of our transmission grid to serve this crazy amount of energy requests. But it was a realization of actually doing a check on the rating methodology and identifying that the process that we are all now implementing is based on knowledge is power, of what was known and what was able to be received based on in the 60s and 70s. And what that meant is our very dynamic transmission infrastructure, and dynamic means changes over time with multitudes of variables. And two of the variables that were static in the rating methodology was temperature of the current, where the specific asset is, and wind speed, which, fundamentally, I was studying transmission systems for 15 years at this point, and I always took the rating as the Bible. There was some ingenious work done. This conductor can only handle this much current flow. Therefore, this shall be what we run our grid against. And so I think my ability to question something that was and drive an organization to think differently is the crux of why we're at this static, almost stagnant moment in transforming our grids as we know it. So I will say, like, what your capability can do and dynamic rating in itself is it's a sensor, it's a measurement, and you can get into the details of the actual structure. There's many ways now we're learning that you can deploy this type of technology to pull back and receive information that we never had access to. So, aka knowledge is power. Is that what you said? So,
Yeah. Power of knowing.
Power of knowing. Yeah.
Yeah. Mm-hmm.
So DLR is so much more from a not just a specific use case, right? And I think we get stuck in our industries. What is the use case? What is the value? What is the cost?
Yeah.
And then we forget that changing the rating of our static infrastructure that we've built a grid on for 100 years will kind of like rattle some folk, right? The utility owners of the assets. So thinking about that and really dealing with the utility space over your time at your company, what do you kind of as your approach, or really how to approach or think of, deploying and really taking these technologies as a reality and, install them, because we can't find the value of it unless it's out there, right? So what's your experience of, how those common challenges of like what utilities do face to really say, yes, let's do this?
Yeah. And I think that there are several challenges in that. And, today, less than 1% of the grid has sensors on it. So it's all analog. It's just, like you said, historical ratings of that has been set with calculations, right? So it's not real time. So less than 1% today, but dynamic lane rating has been around for decades.
Mhm.
And it's really just today that the technology is advanced where you can do it system wide, and that really can be deployed both physically and then economically, right? But yes, the utilities, of course, you're asking me about the challenges for them. It is, as you said, it's an old system, right? So the transmission grid in the US is often referred to as the world's largest machine. And it really, it's aging, it's been around that long, and the utilities are used to, I mean, they are responsible, of course, for powering the lives of all of us, right? So they have a huge responsibility, and they, rightfully so, their culture is conservative as it to implement new technology, right? So the struggles they have, of course, this is going on their lines. This is going to give them new information. It's also going to be connected to their system. So it's more, they need to learn how to use this, how to operate in a different way than they have before. And it's all that to get the buy-in and make sure that they get comfort around that this is actually giving the right information. So it is, in the industry, we say that utilities like to pilot to death, or death by pilot.
Yeah.
Yeah, they like to do that with all new technology. But what they really, I think, is important for the utilities to think about is that the time of the deployment, that they need to be able to do it quickly, and time to return. I also think that ensuring that they are choosing a technology that can be deployed system wide is important. And I also think that they need to look at the additional applications that can be done through these sensors, right? So time to deploy, I'm just thinking about that first, something that can be deployed quickly so you can start actually getting these benefits of having this on your line and actually taking care. So we say that we increase the capacity on the line, and that they have 30 to 40% returns. And it's the biggest that I can think of in any, thinking about my industry experience of any investment, that you can get such huge returns on your investment so quickly. Actually, that was the capacity. If you look at the percentage from what the cost is versus what you gain, it can be in like thousands percent. So it's enormous. But there's also, more importantly, you can find out that you don't have the capacity. So that's important also. But so really, time to deploy and making sure that you can do it quickly so you can either find out you don't have the capacity or that you can actually use it. But then I think that really encourage them to do deployment of system wide, because if you are thinking about just doing in your congested area today, that could be a game of whack-a-mole, right? You will do that, and tomorrow it's congestion in some other place, and then you have outages, and that will really help you to route power to the right places, right, where you actually have capacity. Say you have a planned or an unplanned outage. But also these other applications, such as icing on the line, you have fire detection that you can do through these. You also, have fault detection, and then also design truth, right? Truth of your design. So there are many of these, but I understand that this is new to many of them, and especially doing it at such a big scale and doing it like beyond piloting can be some of a discomfort. Yeah.
A lot to unpack there. And I feel a little bit, well, one, I don't think listeners, if they heard my DLR speech before, I can't help but interject, what, and really break down. So you said something that like might have, if you deploy these technologies, there may become a day or a condition on the system where the rating that you assumed was the rating that you could push your line is actually less. And so it's scary words like that in the industry that like the non-first movers and or fast followers will latch onto and prevent them from moving. So I want to just share, like, I think, everything that you said is completely correct, right? There's like multitude of use cases that become a reality, right? The whole icing thing is a big one, right? The idea that we as an industry don't fundamentally know when there's ice sitting on our transmission. It's never been something, we concerned with, but that's only going to become something more of a reality, especially with the colder temperatures. So now you have knowledge. The other is like, galloping.
Yeah.
That's also a condition from your asset management perspectives. You want to understand, is that happening? How often is that happening? Where can we do? And I think another tidbit that you said is like, as we load up these lines, what changes, and I remember, sorry, sidebar. I remember I was driving down a highway with like an intern when I worked as a power systems engineer. And I said, oh, look how heavy those lines are. It was like a joke, He's like, do you actually think that the lines are heavier? And I'm like, no, I was just, that's what we say. When it's hot and they're fully loaded with electrons, it expands the connector. But I just remember that conversation, like a word I chose, like, right, when I said heavily loaded, he was like, completely like, you must know nothing, right? And I was like, no, I know my stuff, but genuinely, like, that sag can cause a lot of burden, aka the 2003 Northeast blackout, right? There was a sag that happened into the trees. But anyway, so you can monitor and like redesign your sag, which is like a huge benefit to DLR. Anyway, I just want to capture a lot of the use cases you said are actually very incredibly valuable to the overall awareness of the system. And so one thing about utilities, I would say, like, deploy DLR before you have the IT or the infrastructure available to receive this real-time data will set a tone within an organization of like, it's useless and why are we doing this? Because we're not even tapping into the data. Like, that's a trend. So we have to get ahead of that. Like, we must have the visibility to create information databases that we have not yet had to allow us to then expand and really develop a new way of thinking. But we can't get that knowledge or that data until we deploy these sensors and technologies. So you said a proponent of full scale deployment.
Yeah.
So I guess for our listeners, like, there's a lot of transmission out there. And so, and their utilities own a significant amount of wire mileage. So what is that process? How have you guys streamlined the sensor installation and, deploying it in a rapid phase? Because I think that's important, right? Like, how does it get up on the lines and how can it happen quickly, as you stated?
Yeah, it's, as I said, that it's been a lot of progress made and with the technology. So our sensor, which we call the Neuron,
Love it.
it actually, it's mounted on to the power line by drone, so autonomous drone. So it could really be deployed anywhere on the system, over a fjord in Norway, inside a mountainside where you can't get the truck, and where it's so it's really safely installed also, because you don't need anyone to be climbing to install our Neuron. But this groundbreaking, technology then of getting this up on the line by by the drone really is proven to be done, well, very quickly. We could do many per day. So whereas you would have one installed per day, maybe in the past, we can do several in one day. So it's very quick. Once the drone is positioned up, it then goes to the line and it takes less than 10 seconds for it to be installed. So it's very quick, it's safe, and it actually draws and it energized from the line itself. So it starts sending back information immediately. So it both has cellular and satellite capabilities in the neuron. So it starts sending back data immediately for the utility to start understanding what's going on with that line and learning. And then it's, of course,
does the line need to be de-energized before you install?
No, it's on live lines. It goes up to the lines. That's sorry, that should.
Yeah,
So it's energized. So you don't have to turn off have an outage to install these. They go on live lines and start drawing power from them immediately. It also has a backup battery in it. So should the line be out, it has backup for 6 months where it will continue to send data. And this is important. So we talk about icing. Say it's in an area where there could be icing. It would still send back information to the utility on the condition of that line for the 6 months out. Yes.
I mean, so just for our listeners, one thing I learned being in the industry for 15 years, coming into the utility, and like the transmission system, if you're within an RTO ISO of the states, which is like PJM, ISO, SPP, they are kind of the utilities that report, aka are a member of these entities, give over the kind of responsibility or functions of scheduling outages. And so what that means is PJM overseeing, multitudes of utilities, aka multitudes of transmission owners that are fundamentally required to do maintenance on their transmission. So there's a whole very complex set of humans and data and analytics that are in the back and will only be enhanced and optimized as we get more knowledge. But scheduling who and when and for how long these large, massive pieces of infrastructure can be taken offline. So the fact that you can install these by a drone autonomously and while the line is live is huge in regards to kind of breaking down some of the obstacles and challenges that, we've evolved from over the last 20 years. As you said, this technology has been around. And so another thing, there's a lot of buzz, so I am very careful with my words, around this whole AI, right? In the get space, but really, for the DLR, practically speaking, how does AI play into really these DLR solutions that you're talking about?
Yeah, so if you think even of AI, how it's now kind of getting a bad rep in the energy industry because it's using so much energy. So I think like 1.5% of all is used to power AI, and they said this is going to double by 2030, which is now only 5 years away. It sounds much longer, but it's 5 years away. But the thing is that the AI needs energy to run, but also like our CEO says, the energy needs AI also in order to optimize and to the information that's coming in. So
it's like a double-edged sword, right?
Yes.
What you're saying is the utilities need this data for full situational awareness to understand the response of the system that we've never had. And to do that, it's a massive amount of data that we will then build the infrastructure, aka software, hardware, and kind of architecture of like the IT world. When we say infrastructure, not transmission infrastructure, we need to run very complex, heavily utilized servers and or cloud services to get these answers. So it's like a double, but we also are being asked to serve this enormous amount of energy to run said models for everyone else too. So
absolutely. Yeah, that's exactly right. So we have developed algorithms to then take this data and from our sensor and then determine the real-time then capacity, and we'll also give you some predictive out in time as well. So we 10-day forecast out as well on what what is to be expected about that line going forward. So it's learning, it's machine learning at the same time.
Right. So like the sensors themselves, for our listeners, will become more informed and more educated the
yes,
longer that they're energized on our assets. And so what you're, on top of developing the sensor to capture the real-time information and to ultimately like reserve it on a cloud, you've developed all of the various AI models that will learn and become more intuitive. And that's kind of where the AR part.
yes,
So for any utilities looking to say, how are you using AI? That's like
yeah.
another.
Exactly. They're using AI. So really the grid should not be the bottleneck for AI. It should be the launch pad, because they were so dependent on the energy, and it, as you said, it is the energy will use the AI to produce and provide more efficient energy for society as a whole.
I have to take another. I'm going to plug. So actually AEIC, which is the Center for Operational Excellence, which I'm the program director of, is we're running these series of workshops. And so the utilities are being asked on continuous repeat from all business units of
Yes.
like, how are you using data? And I think we as a society, we choose words and then we create a lot of buzz around it. And then we shoot it around our industry and everyone kind of takes that, right? So I think we're actually kind of grounding ourselves to before AI can be effectively utilized in a system or an application, especially in this complex grid that we're all speaking of right now. There's some foundational needs, right? So you need your data source, which is high quality, real time, and historical data, which a lot of people will be like, just so they cannot make progress. Well, we have bad data. That's not true. If you have data, it's data. There's methods to clean it for all of you that are saying that. Anyway, look at me scolding my listeners. The other one, though, is data collection systems. So it's like the stack for which the data is being brought. So when you think about your device, you're creating an opportunity to create a data source. You're creating a system to collect the data. And then you have built the technology to integrate it into the systems of the utility based on
Yes.
knowledge.
It's exactly right. Yeah.
And that's a huge lift too, right? So when we think about like deploy this technology, well, then you have to have the systems that can easily be integrated. Maybe we shouldn't say easily, can be integrated through a process, which you've done, which is a success, right? And then you have to be able to store and manage it to then be able to run these AI models. So on top of not only the sensor that is delivered by a drone, autonomously attached during a live line, you're also giving some of that fundamental infrastructure to then deploy.
We have the software that integrates into the operation system of the utility, where they can start using it immediately in their operations.
Right. And the utilities as a whole, we're at a space where like that vendor utility partnership, that ecosystem, has ever been evolving. But now in this world where the technology is rapidly evolving, it's like gaining accessibility and awareness of who the players are and what that is. It's going to take many, right? And there's a significant amount of transmission that we need to deploy this technology on. So, we got to get started. So I love hearing about it. I love hearing that there's other solutions, right? Because there's only so many people that can fly the drones and implement them. And that's another word we should talk about, right? Implementation is a little bit different than integration, which is like a whole other, expertise that can be partnered with your organization. I love it. Sorry, I'm getting a little excited. So thinking back on your experience and just like how you came into this technology and really what's driving you, like knowing all of the other industries you played with and, what makes right now different and like, how do you, like, what gets you kind of out of bed to like know that this is, where you want to be and where you want to sit, and just knowing all that history that you have, like what comes to the table for you?
This is a time where we are increasingly, our lives are being powered by electricity, right? So you have electrification of transportation. You have the data centers that we have just spoken a lot about. It is, there's just so much that is now transferred from being petroleum based to going into being electrified. And that just shows that it is important, like with reliable power, like you said, the data centers can't be out And then we hear a lot about that as well. So it's right now, when you look also at the transmission grid, as I said, it's the world's biggest machine. It is old and aging in the US. About 70% of the lines are over 25 years old. And some of them are really approaching that 50 to 80 years of life expectancy. So it was built at a time when we didn't have all the renewable power that we have now, that coming in, intermittent power that used to be dealt with. And then you also have the different type of then demand, as we talked about, the electric vehicles and also the data centers that actually have very volatile, the demand is varying throughout the day. And so this is really the time why dynamic line rating is so important right now, because it will help the utilities as they're planning for building out the very needed, build out of more transmission, because that has to come, but that takes time. So this is a good time in between in that planning phase. You can use it during the planning to know what to route power during the construction, but you can also use it to get as much out of the existing system as you possibly can before you build more new, or you can push it out and actually optimize what are you going to build out first. And this makes me think of Jim Rogers, who was the CEO of Duke Energy when I first started many years ago. And he's called energy efficiency the fifth fuel. And he said it's the energy that we didn't have to produce. And the power plant we therefore didn't have to build now. It will come later, but it will be able to push it out in time. I liken that to the DLR today, right? So this enables the utilities to squeeze out what they have of the system, or even know where do I need to make my first investment, and help them during the construction with the planning, and really get most out of it, and maybe push some of the spend out in time. But there's no question the new transmission is needed, but this will just be helpful in that whole phase. So that it's a good time for DLR. Yeah, it's right. It's the right time.
And I heard you a couple times, like there's also this ideology. Can you tell I've ran into a lot of the naysayers?
Yeah.
Trying to be kind. We are being, when we have this ever increasing demand. I mean, I think now more than ever, especially in the last 3 years, like the hockey stick load requests that all of the entities are now, seeing. And if they're not seeing it, they want it. And we only have the grid that exists today. And as you mentioned, it's aged. So, we got stuck on this conversation about integrating renewable, but it's really integrating new innovation, new technologies, utilizing, or really leaning in on the awareness that we did not and need to have this awareness that we now have the availability to. And so almost like from a short-term perspective is having these devices that can bring back this data to kind of create that full situational awareness of your transmission grid allows us to baseline the current system's performance so that we can make decisions on our aged infrastructure, right? Like we get stuck on this intermittency, and it's important, it's valuable, and it's another technology that can be a part of the larger solution. So, there's a short term of getting through kind of the interconnection queue, really understanding the current capacity so you can build your models and maybe start optimizing differently, because there's a whole world on like system planning and how you actually like interconnect. But this could be a gap filler, kind of bridge that awareness by truly understanding where the system sits today. And I think there's a lot of comparison to like AMI data. Like we've like demonized advanced meter infrastructure, which gives this real-time data of the edge. And if you peel, you go all the way up. I mean, this is like real-time data for the transmission. And all that will do is provide insight to the utilities to make better decisions on how to enhance the aged infrastructure to prepare it for all technologies, just like not some subsets. So I want another soapbox. So thanks for listening. Another big area before we wrap it up, and it's just, everything that we talk about is in a space of, AI, data, technology. There's like this big thought that it's like going to remove jobs, right? Or like lessen the need for jobs. And fundamentally, there's a whole space that I think electric utility is aware of, that the workforce, right? Who needs to be involved and how exciting it is to become involved. And there's many spaces that like we need that talent. So from your career, your journey, like what is food for thought? Nuggets of wisdom for our learners that are our listeners. We have a lot of students and grad students that want to be
Yes.
a part of the energy industry. What would you kind of give them from your perspective and what you've learned over the couple decades?
Be versatile. Make sure you want to learn as you go. And I think now, of course, AI is important. It's really important to understand it and take part of it in the energy transition that we're in, and make sure that it will really create opportunities if you're the one who's going to work on the implementation of GETs, right, grid enhancing technologies. I think there's going to be a huge opportunity there for people to get great and very exciting roles, right? I believe that the entire grid will be digitalized, so we'll be able to see, because it makes complete sense. I think it's a no-brainer, but I understand it's going to take time. And if you think about, there's resistance, of course, but if you think about that McKinsey study, I think it was in 1980s, where they said that there will be 900,000 users by 2000 of cell phones. It was a cell phone study, but it turned out there was 109 million or something. So it was off by 99% wrong on their prediction. I think it's the same thing here, that it really is going to go grid wide. When you think about also your analog, your regular phone, right? Would you want to go back to that? And once you got the cell phone, no one wants to go back. Once you have the GPS on your phone where you can see the map, you're not going to use the paper map anymore. And I think that once that utilities see what this can do, and actually everyone in us end users of the energy too, because it's going to drive down the cost for us end users. Once you know about it, you're not going to want to go back. And I think that's where there's going to create lots of good opportunities if you embrace the technologies and you want to be part of implement. If you're going into the energy industry, which of course that's where I spent my entire career, exciting space. I think just embrace the new technologies and be the one to help it move forward.
So be curious, never stop learning, be bold, and take the risk. So get in it,
Take the
love
risk.
it. Okay, well, thank you so much for jumping on, sharing the technology and kind of where you're at in the industry. I look forward to seeing your journey and hearing about it in the future.
Yeah, thank you so much.
That's a wrap for this week's episode of the GridMod Pod. Thanks for tuning in. We hope today's conversation got you thinking about new and creative ways to improve our power grid. Be sure to subscribe to our YouTube channel to be the first to hear new episodes. This podcast is brought to you by AEIC, the place where operations leaders come together to share knowledge and provide guidance to the electric utility industry. We'll be back with a new episode soon. Until then, keep powering on.